Right. So I'm curious, we talked about endogenic forces like plate tectonics and exogenic forces like what's the sun is doing, right? And Milankovitch cycles and things like that. Those like really far away forces. But we haven't really talked about what is on the surface of the Earth. For example, biology. So do you think biology, which lives on the surface of the Earth, is an endogenic or an exogenic force? And I want you to explain your answer. Um, know that I'm not grading on right or wrong. I am grading on thoroughness of logic. So really explain what your answer is here. I want to know what you're thinking. Okay, so continuing on. I'm thinking about on the seafloor, right? We know that the crust of the seafloor is made up of basalt. But when you dive down to the seafloor, most of the time you're not just going to immediately hit basalt. There's going to be a thin veneer or a thin layer of sediment on top of that basalt. And we're going to talk about where that sediment comes from. So the abyssal plains, right, as we talked about, are these vast undersea plains that collect fine grained debris from nearby continents, right? Debris that is that started in the mountains as solid rock and then slowly broke down over time. So the rock itself is endogenic. Forces that break it down are exogenic. That rock breaks down into, boulders, cobbles, sand, eventually down into silt and clay, which is delivered to the ocean through processes such as gravity, rain, rivers, wind, things like that, bringing that sediment down to the ocean, depositing it into the abyssal plains. So most of the sediment that is eroded and worn down from the mountains is carried down to the oceans by rivers. Some of it's also carried by wind and gravity. And when it gets to our continental margin, meaning off the land and just barely in the ocean, in the shallow depths of the ocean, right along our coastlines, it tends to build up there, right? Because it goes from an area with rivers and rain, all of that transport energy into an area that's below the sea surface. When it gets below the area where like waves can't move it around anymore, the water is very calm. It just most of the time just sits there. So it builds up in our continental margins. And then in order for it to actually get down to the abyssal plain, rivers aren't going to do it. Wind isn't going to do it. It needs another force to do it. And what often happens is that it'll build up into a pile on the continental shelf. And then eventually there's some sort of catastrophic event. For example, there's an earthquake that triggers an underwater landslide, right? That's super common. We call those like big turbidity currents. And there'll be a huge pulse of sediment down to the abyssal plain all at once. But again, most of that sediment, even as it goes down to the abyssal plain, hits the abyssal plain close to the continental shelf, right? Close to that continental margin, and then stops. So right along the edge of our continent, we have this huge buildup of sediment. However, that sediment doesn't have an agent, a transport agent to actually get it to the depths, the rest of the abyssal plain that is far away from the continent. But there's still sediment out there, right? And most of the sediment that actually deposits in the abyssal plain far away from our continents is not washed off the continents, but instead arrives to the seafloor as a continuous rain of particles that we call marine snow. That means it's not being washed off from the continents. Instead, it's from stuff that used to be suspended in the ocean column. We call that stuff pelagic because it was in the ocean column, as opposed to benthic, which means actually on the seafloor. So this pelagic stuff, such as tiny little marine plankton, um, dust that is blown into the ocean, there's not a lot of it. However, the ocean column or all of that water is really, really deep. So when you sum all of that together, as that stuff slowly falls, as the plankton die and slowly fall, as the dust settles and slowly falls to the ocean, it really is like a continuous rain of organisms. And if you put a camera at the bottom of the ocean and just watch, it looks like you're in a snowstorm, right? Because all of that marine snow is coming down. You can also, so I talked about things that came from Earth, like plankton and dust. You can also get cosmic particles, right? So like little bits of meteorites and things like that that were outside of our atmosphere, came into our atmosphere and then settled into the ocean. Those cosmic particles can also deposit on the seafloor. And through geologic time, even though this marine snow is a very slowly accumulating process where this pelagic sediment builds up, even though like each year the deposition is tiny, if you think about it, how much time this marine snow has been depositing, we can actually get a layer of sediment a few hundred meters thick, right? That is a ton of sediment that is built up on the seafloor from this marine snow. Um, Relatively, it's a thin exogenic veneer, right, compared to the endogenic oceanic crust, which is basalt. But on a human scale, right, a few hundred meters thick, it's a lot of pelagic sediment. That's a lot of marine snow that is settled. And we've been coring the sediment to figure out what's in there and be able to track through the layers, like what organisms have lived and died, how much dust there was there, what are those cosmogenic particles doing through time. We've been able to core the sediment, and the oldest sediment we've ever found is about 100 million years old, which means that there is a continuous record, this slowly depositing historic record of what was in the oceans for the last 100 million years. Yeah. So recall, if you can remember, most of the sediment accumulating on the deep sea floor away from the continents is sourced from where? And about how much geologic time is recorded in the soft sediment that has settled to the seafloor.